Okay, I'm Nita Couchman. I'm the president of the Orcas Island Garden Club. And we are so happy today to have Russel Barsh here to talk to us about bats in the San Juan Islands. I hope that most of you got the March newsletter in your mailbox yesterday and are finding things that are educational, entertaining, inspiring, just fun about gardening. As always, we invite ideas for other articles. Member input into the newsletter is always welcome. So if you have some ideas, please let us know. And without further ado, I think I'll turn the program over to Lena, who will introduce our speaker. So enjoy.
Thank you, Nita.
Lena, you're muted. Can you start over?
Sorry about that. So I just wanted to welcome all of you and to say that I'm going to start with some housekeeping things. And those are that if you will mute your personal mic, also your personal video, and if you will select speaker view, all of those things will help us to get better quality from Russell's presentation. If you have questions, please submit them through chat, and they're going to go to Holly at the library, so that you don't need to send them to everyone, just to the library. And think about them as you're going through and post them. And then at the end, Holly will address them with Russell, who will respond and answer our questions. I'm very pleased to introduce Russel Barsh. Just an aside, I have been enjoying his book about bees that came out from Quiot and other things. So I was delighted when Perry Gibbons said that she'd heard his presentation about bats and thought that we should ask him to present today. So thank you, Perry, for that suggestion. For the past 20 years, Russell has been the founding director of Quiot. Quiot is a nonprofit conservation biology laboratory that studies island ecosystems, marine and terrestrial, and works with the public and private landowners to protect our most unusual habitats and species. Russell is best known for his research on the food web that sustains Chinook salmon and killer whales, but describes bat ecology as his hobby. He made his first ultrasound recordings of bats nearly a decade ago with zoologist Ella Rowan. He estimates that he has visited more than 200 island homes with bats. A lot of us have bats in the Belfry, I think, and recorded nearly 500,000 bat flyovers. He is going to tell us about new research findings that add to the understanding of the role bats have in regulating insect pests and why bats make the San Juan Islands safe for gardens. I suspect we will also learn what we can do to make our islands safe for bats. Russell, thank you so very much for joining us. We will mute, close our videos, and select speaker view to enjoy your presentation. Thank you.
And let me see about giving everyone this screen. How's that? Okay, I'm just checking to make sure that people can see the slideshow screen. Is that working?
Yes.
Good. Okay, then we can begin. Just want to make sure I can share some cool pictures and some graphs with you from recent research, and let's dive in. We'll dive in with a picture that I enjoy. Let's see, now we have issues with our with my screen. Wonderful. I seem to have a frozen screen. Let me just see what's going on. There we go. Okay, it had to think for a while. Okay, there we go. Well, that's a good introduction. I would have to say that bats are not necessarily everyone's cup of tea, but I find them very cute. This is a picture of an outraged long-eared myotis in care at Wolf Hollow a few years ago, and you can see it's so tiny and fragile. Bats are the most amazing creatures because they're smaller than mice. They're thin and delicately boned, and it's almost impossible to imagine that anything so small could be so clever and also so sociable and have such complex behavior. So for me, studying bats is part of being amazed at the mystery of evolution, and to me they are kind of cute. The thing to look at on a bat like this is the little opening between the two upper canines. It looks like is missing all of its front teeth, and that actually is the way bat dentition works. At least the bats we have here in North America. That's so that they have a space to suck insects in while in motion. So it's an insect vacuum that is that space between the upper canines. Okay, now it's working. So just a little background on bats generally. We have two bat evolutionary clades, two kinds of bats in the world, quite different from each other, though with a distant common ancestor about 70 million years ago. The megabats, which get most of the publicity because they're kind of cute, they have little foxy faces, big noses. People see them as very cuddly and cute. They're quite large too. We call them megabats in bat research. They are a group that is almost exclusively fruit eaters. They live only in the old world, in Africa, the Middle East, and Asia, and the Pacific, but not in the Americas. So we do not have megabats or fruit bats in the Americas. If you look at a fruit bat, one thing that you notice immediately is its prominent snout. And fruit bats use their sense of smell as their main foraging sense. They're primarily focused on smelling ripe fruit and smelling flowers. And so they have these beautiful big noses. Whereas the little microbats, as we call them, microbat clade, which includes all of the bats of North and South America, have big ears, little tiny noses and huge ears. They're the bats that tend to be hunting insects and using ultrasound as a way of scanning the environment and targeting their prey. So right at the beginning, fruit bats are nose to smell centric. They are much moving around with their noses, and our little microbats in the Americas are using their ears and ultrasound to find their way, but also to target the insects that most of them eat. We do have some microbats in the Americas, mostly in the Caribbean area and Amazonia, that have gone back to eating fruit. And so they're little tiny bats with big ears, but with a taste for ripe fruit. And they're an interesting group that we unfortunately don't have in our area, not surprisingly, because we only have fruit here for a short time of the year. But if you go to the Caribbean, you'll see microbats with some fruit eating. Notice also, just briefly before we go on, the size of bats. A megabat can be several pounds. These are as big as small cats or dogs, whereas a microbat tends to be about the mass, about the weight of 2 nickels. That's all, just the weight of a couple of nickels. They're tiny. So in North America, we have altogether about 40 different species of bats in different parts of North America, but Our species diversity, interestingly, is concentrated in the west of the Mississippi, though you've probably heard more about eastern bats, Atlantic bats, because they are concentrated in caves. They are a big tourist attraction in caves. They have been the focus of concern for white nose syndrome, but the bats in the west, particularly the southwest, where you see the red in this picture, that's where most of our diversity is, where we have 20 to 25 species in the western states, 15 in Washington state, even though we're pretty far north. So western states are the center of diversity for bats in North America. Partly because of the distribution of insects and relatively undisturbed wide open habitats in the West. So here in the Salmon Islands, we have 9 bat species, 9 out of the 15 that live anywhere in the Pacific Northwest. Here they are, here are the species, and you'll note next to the species, we have little 4-letter codes. This is similar to birding, where there are shorthand codes for bird species. We have shorthand codes for bat species. So California myotis is Myotis californicus, scientific name. Myotis californicus, we contract to mica. So we have mica, Mayu, which is Myotis humanensis, and so on. I'll try to stay away from that, but this is the way bat researchers talk, is all these shorthands for the different species. Our 9 species you can see here, 5 of those 9 species share a genus name, Myotis. They all belong to the genus Myotis, sometimes called mouse-eared bats, because they sort of have relatively short ears and little mousy bodies. They're very, very tiny. And then we have 4 larger bats belonging to 4 different genera, and they're quite distinctive. But a big bat, for microbats, a big bat is the difference between 2 nickels worth of mass and a couple of quarters. They're still very tiny, songbird sized. Let's take a closer look at our local bats. Let's get to meet them. The most common bats here in our area are these little mouse-eared bats led by the California myotis, mica, and the Yuma myotis. Californias and Yumas are interesting here in the islands. They haven't been studied very well elsewhere in the region, right? So this may be a more general observation, but here in the islands, they are distinctive for one thing because they skim lakes and ponds to drink. They just fly low over a body of water, drop their jaw and skim the water out, so that they don't stop and drink the way birds do, or small mammals generally. They drink on the fly, and they hunt over water. They're primarily focused on ponds, wetlands, big insect swarms. And here in the islands, and this is what's really so special, they also hunt over beaches, tide pools, rocky shorelines. They use the edge of the ocean as a hunting ground, and they are able to target a large number of insect species here in the islands that lay their eggs in the intertidal zone, even in tide pools and salt water, and in the wrack and the vegetation on the edge of the beach. So our Californias and Yumas are very much focused on the edge of the land, where the land meets the sea. They can form very large roosts. I know of 5 or 6 roosts here in the islands that are between 500 and 1,000 Californias and Yumas living peaceably together. And as we'll see, they are often found in nice, warm buildings like people's homes, in attics, and in the peak of barns. So you're going to be more likely to encounter them, and encounter them in large numbers, than any of our other species. Now, we also have 2 relatively common large bats that people often see that also like to live with people, that also get along with people and are happy to live in attics and in eaves and crawl spaces and the tops of barns. Our big brown, which is up in the upper corner here, big brown looks like a big mouse-eared bat, about 4 times the bulk. And our gorgeous Townsend's big-eared bat, which is a federal species of concern, a state species of concern. It's a relatively, on a national scale, a relatively rare bat that thrives in San Juan County. And in fact, more of them live in San Juan County than anywhere else in Washington state. We are still discussing why that might be, but we here in the islands are a refuge, a refugium for Townsend's bats. And with their huge bunny ears, their rabbit ears, they are distinctive and identifiable even when they're flying. If you see one backlit by moonlight or by the fading twilight in the evening, you can even see those ears when they're in full forward flight. Very distinctive. We get more calls about them than any other species of bat because people recognize them right away, as opposed to all the others which look pretty similar. They're a little small and brown and look mousy. One of the cool things about the big browns, though, that I want to point out is that they seem to like mouse-eared bats. And it's very common to find roosts where Yumas, Californias, or little browns are living together with big browns, and they all live in a big multi-species community. That's very, very cool. Now, we also have a couple of bat species here in the islands that are unlikely to be found in a home or a barn or close to people. Our silver-haired bat and the hoary bat, which is our largest bat. It's actually the largest bat in North America. Some people call them teddy bear bats because they have big round faces and they're fuzzy and look very cute. Although again, they're about the size of a chipmunk. These are bats that prefer to roost in the woods. They use tree cavities. Other bats do too, but these two species are very unlikely to roost anywhere except in a tree cavity, and that which makes them quite vulnerable as forests change or disappear here in the islands. The hoary bats may migrate, and just put that in the back of your mind because we're going to come back in a minute to what bats do in the winter. But hoaries have been tagged elsewhere in North America, and some of them migrate not just north and south, but east and west. They're big long distance flyers, but without any clear pattern. And we have no evidence yet that the ones that live in the islands fly away from the islands. They seem to stay here, which is also true of our other bats. But it's something to keep in mind that this is one bat which elsewhere, say in California or in the American Southwest, we would expect to see migrating seasonally like birds. Most North American bats spend the colder months, spend the winter hibernating, frequently in caves, if caves are available, and if not, in tree cavities or in buildings, wherever they can find a warm, undisturbed space. What's really important in current terms is that it's this winter hibernation that makes bats vulnerable to diseases like white nose syndrome. It's a disease of hibernating bats and is most dangerous in areas where bats have long winter hibernations, 4 or 5 months asleep in a cold, damp cave. So that hibernation is essentially a bottleneck biologically for bats, where they're very vulnerable for several months. And that's what's getting our bats on the East Coast. But here in our area, in Western Washington, or the Salish Sea generally, this includes Vancouver Island and the lower mainland of BC, bats don't appear to hibernate. They disperse in winter. That is to say, they spread out over the countryside as the number of insects per square mile decreases in the fall, the bats spread out to take advantage of larger territories. And so they are less frequently seen. There are fewer bats per square mile at night on good, clear, relatively calm nights when they can still hunt. And they spend during the winter maybe half to 2/3 of their time napping, not hibernating, not going into this deep coma that hibernation represents, but doing something we call torpor, which is just deep sleep from which they awake every few days to take a drink and to get some food, and then they go back to sleep. So there's this dispersal and periodic sleep and foraging behavior that's typical of our region, and it's quite interesting because this is unique. Other parts of North America, bats either hibernate or migrate, and here they just hang out, low activity levels, spread out. They're less conspicuous to us, but they're still active. And why? Because we're warm enough to still have insects, mostly moths, emerging in the winter. And we're going to take a look at some of those winter emergent insects that are of concern to gardeners and bats alike. But first, I just want to make a point that one of the reasons bats do relatively well here, despite the fact that some of our winters are really cold and nasty, like part of this winter was, lots of snow, lots of wind, is that bats have grown accustomed, at least most of our species have grown accustomed to living in people's homes, which are warm and dry, like these big browns living in somebody's attic. Bats in the San Juan Islands seem to mostly seek shelter in people's homes. And at first that seems very odd, and you might think, well, what did they do before? I mean, how long have there been houses here in the San Juan Islands? Well, the answer is for a very long time. Let me just go ahead for a moment on this. For a very long time, because native people, Coast Salish peoples here in the islands, were building wooden houses 2,000 to 3,000 years ago. So bats have had thousands of years of living in people's warm, dry houses here in the islands and over much of the Salish Sea. And as indicated here in the upper left, bats figure in Coast Salish art. This was an animal that people were used to living with and used to looking up and seeing inside their houses for millennia. So this relationship between bats, especially in their need for warm, dry conditions in the bad weather months, this relationship between bats and people goes back a long, long time in our area, probably at least 3,000 years, maybe as much as 4,000 based on the archaeology of cedar buildings in our area. And just backing up for a moment, one thing that I want to emphasize is there are really two ways that buildings make a difference in bat survival. One is certainly in winter when they really require warm, dry places to do that napping, that torpor between the few days every week or so that they can get out. The weather is good enough for them to fly, and it's warm enough for some of the insects like the winter moths to rise and be vulnerable to bat predation. But the other thing is in spring, mother bats congregate to give birth to their pups and to nurse their pups. And that's what we call a roost or a colony. It's lots. These are Townsends in here. That's we counted them about a month later, and there were 167 in this colony. Mother bats and their pups living together in an attic, taking advantage of the heat and the dry, in the springtime, when it can be very stormy here, and it's a lot safer to raise and nurse your pups in a nice warm attic than it is in a tree cavity. So bats use people's homes here in the islands both as winter roosts, but that's individual bats, just one here, one there, quite spread out. And in springtime, the moms use people's homes, to have safe places to provide the first couple of months of life and nourishment to their pups. So let's just remember again, we'll put that aside for a moment and return to it, that people's homes actually have for a long time played a role in the habitability of the San Juan Islands to bats. So mothers and pups, this is a great a shot that a colleague took of an East Coast bat with her pup. You can see mom and pup, but pup down beneath there, little smaller, little crunched up features. Mother bats typically have one pup a year. So each year at best, a bat mother is going to be able to produce one pup that will maybe survive. But mother bats can live for 20 to 25 years. So if a roost forms in a building and the mother bats have had successful births and produced pups there for 5 or 10 years, they're probably many of the same mothers, and they'll continue to come back and take advantage of that and return to where they grew up, where they were reared. It produces a long-lasting colony that is critical to maintaining bat populations. So a maternity roost, a maternal roost for bats is like a spawning site for salmon in a stream. They'll keep coming back, and in the case of bats, it's actually the same individuals coming back year after year, the same mothers continuing as long as they still can, birthing one pup a year. I should also mention that pup looks really large, but that's not surprising. Actually, when the pup is born, it's 1/3 of the size and weight of the mother. Imagine what that's like to be a bat mother and give birth to a baby that's 1/3 of your size. But it's very bat to have these huge pups that require enormous amounts of milk. And one of the consequences of that is that mother bats are frantic for about 2 months from the point that they give birth to the point that the pups fledge, like baby birds, begin to fly and feed on their own. During that period of time, mothers are frantic eating enough insects to be able to produce the milk to nurse these huge babies. And when we run the numbers, and this gets us to the theme of the presentation in relation to the garden club, is that bats eat huge amounts of insects, particularly when they have pups. A single maternity colony of 100, 200 bats, very typical maternity colony. We have scores of them around the county that are that size or bigger, will eat perhaps 100 pounds of insects during the period of time they're raising their pups. To imagine that's 100 pounds of insects. That's like hundreds of thousands of insects to add up to a pound of insects. And that would be just one colony raising its pups. Just a few hundred bats, including the babies, will eat that much in insect biomass around here in a typical year between April and midsummer, just the time that you don't want insects eating what you're planting in your garden. So there's been some interesting work recently trying to understand which groups of insects are targeted by bats and where bats have their biggest impact on insect populations. I just put up a slide now that is some Australian data that just came out, and it's from Australian farm country, which is growing a lot of the same things that we grow here. Very interestingly, the dark bars on both sides represent moths. The lighter colored bars are other groups of insects, flies and mosquitoes and beetles and true bugs and so on. On the left is the proportions of different kinds of insects that bats in this study actually ate. And on the right, the proportions of insects that were trapped by the biologists that were flying around. So what we would call the prey field. They were available, but bats didn't necessarily choose to eat them. And you can see a striking difference between what was available, which was mostly actually flies and beetles, and what was eaten, which was mostly moths. This is one of the best recent studies, but as more research is done in Europe, in North America, and in Australia, we are getting a picture that bats may treat mosquitoes and other members of the fly family as hors d'oeuvres, but the steak for bats, the main menu, the main dish, pretty consistently is moths. For the little myotis bats, which are our most common bats here in the Salish Sea, 2 other studies done in North America in the last decade indicate that when mothers are nursing their pups, that about 1/3 of what they eat in biomass terms is moths, which is significant. And so that's spring, summer. And then here in this area, in the islands and the Salish Sea, bats shift almost entirely to moths in the winter. And that's because we are in this interesting climate zone where many moths actually emerge as adults in the winter so that they can get a jump on laying their eggs and hatching out the next generation of caterpillars early in the spring. And we have a very early spring. We're in the middle of it now. This is an adult hop looper, one of the destructive moths that can be a problem in gardens. We were just recently collecting hop loopers off of nettles. This is an insect which emerges in December or January, lays its eggs in midwinter, and then the caterpillars are there to get the first green growth in the spring. And those are exactly the most irritating insects if you're doing any early spring gardening, and exactly the insects that bats depend upon for their winter food. So that then brings us to an interesting historical connection with the islands. The San Juan Islands were the cradle of the orchard industry in the Pacific Northwest. Long before Eastern Washington began growing apples, we were growing apples and pears and plums and shipping them to Seattle and to San Francisco from the San Juan Islands 125, 130 years ago. And our orchards were planted, unfortunately bringing over all of their insect pests with them from Europe, from the East Coast, which had in turn gotten them from Europe. And so with our orchard industry and our wonderful apples and pears here in the islands back in the late 1800s came a whole bunch of pests which bats like to eat. And the bats have become a critical biocontrol of European pests on European tree fruit crops. So the interesting connection. They're native bats, but they have adapted to becoming a key biocontrol. And this just is an example. There's one group of moths. The scientific name for the family is the tortrichids. The most familiar one probably to many of you will be codling moth, which is quite widespread here in the islands. but all of the listed groups of moths here, so particular pests like the plum fruit moth and cherry fruit worm and such, these are all tortrichids. They're closely related, and they all follow this strategy of early emergence to get into flower buds, into the earliest forming fruits, to take advantage of all of these beautiful tree crops that we have that start flowering in March and April and already have some fruit growing on them by early summer. So again, if we drill into orchards here in the Northwest, bats are interesting because they are likely to be targeting the adult moths when they emerge in December, January, February, some now in March, but now shifting over at this point in time, we're shifting over more to the caterpillars, developing on their plant hosts, on their tree hosts, and the adults, but the adults were most vulnerable earlier this year when the only thing that was really flying and was out at night dining on moths were our dispersed, periodically emerging bats in the area. So bats become critical biocontrols, specifically of groups of moths like the tortrichids that have this early emergent cycle that's tied to early flowering fruit trees. Very, very interesting, unsuspected connection, again, between native animals and introduced plants and pests. So, how well are our bats doing? This is an interesting question, and one that led my research. This moves now to what we've been doing here in the islands of research for the last 7 to 10 years. It's not easy. Bats are very hard to see. They're echolocating, so their vocalizations are beyond our range of hearing, up in the ultrasound range of up to about 130 or 140,000 hertz. So something way beyond even what other mammals can hear other than us. How do you observe bats? How do you tell how many there are and whether they're healthy or not and how active they are? Very big challenge for bat research for years that's finally getting resolved as a result of shifting from catching bats and looking at bats to listening to bats using new generation acoustic equipment, electronic equipment that allows us to eavesdrop on bats at night and hear their navigational chirping, as well as hear some of the vocalizations they make to each other. Like birds, they talk to each other. And they also, bats have this wonderful thing where when they swallow an insect, they make a little happy noise, kind of like, woo! They're just delightful little noises when they actually swallow an insect. So you can actually count how many insects are eaten per minute by recording what bats are vocalizing. You hear them traveling, targeting insects, eating insects, and communicating with each other by slowing down their vocalizations to where we can graph and listen in at an audible level and use computer algorithms to sort out the chirps that we hear by species and count them and get accurate counts of how many bats flew by one of these recording instruments minute by minute and every night for months and years. So it's an activity recorder in the broadest sense, and as such can allow us to very precisely measure how much activity each species is engaged in around a particular recorder within several hundred yards of a particular recorder. We now have 5 of these recorders working in San Juan County. 2 are on Orcas Island. 1 is in Crow Valley, and the other one is up at Eagle Lake. 2 distant parts of the island, but both very batty with very high numbers of bats, and as such, very good listening points to get a sense of how activity patterns and activity levels, the extent of activity is changing from day to day or night to night and year to year. And at this point, I think we have over 500,000 recordings. We're adding them up at about 100,000 to 200,000 a year. So that's a huge database that requires a lot of computing power to analyze, and is really hugely rich in information. So let's just take a look at what we're hearing. And I'm going to focus on Crow Valley because that's a recorder that's been going without any interruption or problems now for almost 5 years. So this is what August last summer looked like from the point of view of how much bat activity there was every night. So the scale, the horizontal scale from left to right is successive days of the month. And the vertical scale is how many bats were heard flying over the recorder at Crow Valley. And it goes up to about 500 bats going over in one night in late August. This is a stacked graph so that the top of the color is total bats, and then it's broken down by some of the more common species like the Yuma bats, which are the blue on the bottom and are one of the most common bats in the islands, as I noted before. So this is total bat activity broken down by a few species. And the thing that you should notice here is it's not a straight line. it's a sawtooth. And there can be 500 bats flying over the recorder one night in August, and then 3 or 4 days later, there are 100, and a different mix of species. Bats are moving around every night. They don't go out like people going to the pub and go to the same pub every night and drink the same pint. One night they're going to one pond or wetland or seashore. The next night they're somewhere else. The next night they're somewhere else. A week later they come back. Meanwhile, other species are moving around. Bats are targeting swarms of insects in a way that's extremely complex and means that they are rarely in the same place more than a few nights in a row. Very important to know that. They are not consistently using the same places for long periods of time, but they're utilizing larger landscapes moving from night to night. This is by now, instead of a stacked graph, we're just using ordinary graphing, line graphing of 3 commonest species on Orcas Island: the Yumas, Mayus, little browns, which is Myotis lucifugus, and the Californias, Mica. And you can see that if you look at those, that on any particular day, the relationship between these 3 species is changing in terms of which one is most abundant at the recording site in Crow Valley, which one is least abundant, and also very different in terms of how long they stick around. So that each species is, in a sense, has its own schedule about when the location of the recorder, which is sitting on the edge of a big wetland, when that is the place they want to be to get a good dinner. This is the species breakdown behind that graph. So it's just still August of last summer. And you can see the Yumas most abundant, followed by the little browns, followed by California. But in the background were 6 other species that were coming, but not in very large numbers. And we wouldn't expect that. And it includes a couple of rare bats, the long-eared Myotis and the long-legged Myotis, big browns, silvers, hories, and a few Townsends as well. Townsends do have a roost in Crow Valley as well. So very big differences in numbers, which may have a lot to do with the resources available. One thing is it's farmland. There were lots of buildings, little browns, humas. The Myotis bats like to live in buildings. Not as much dense woodland, which might explain the silver-haireds and the hories not being very numerous, but we're still trying to make sense of the community structure of bats in particular places and why they choose to live where they do. And it's not going to be the same if you look at Eagle Lake or a recorder on Lopez at Hummel Lake or a recorder at Three Meadows on San Juan Island. They have different patterns, all, however, characterized by night to night variation, lots of movement. But we can do one thing. There's one important comparison we can make that makes some very good, important findings. And that is looking at the way in which from year to year, the activity patterns rise and fall, peak when the moms have pups to nurse, and then slowly decline as the babies mature, fly off, colonies disperse. When mother bats come together and when they disperse at the end of the season, changes from year to year. Here in this graph, different colored bars are different years. And you can see that the red bars, which is last year, 2020, is a different pattern than the previous 3 years. For 3 years, we had our bats reach peak activity in June, which makes sense because as far as we know, the norm for our local bats is to have the pups in May. But last year, the peak was in September. That's very alarming. This is very new data in the sense that we just noticed this when we wrapped everything up a couple of months ago from last year's recordings, that we had an inverted, a reversed pattern, where instead of peaking early in the summer when we would expect all the pups to be nursing and gradually falling off and dispersing in the fall, bats got a late start last summer and they really hit their peak just before the weather went bad, which is really, really awful because that means that they were nursing the pups. They were at their peak demand for insects at the time that the weather shifted and the insect populations dropped in the fall. This is something we expect as a more common result of climate change, that we get weird relationships between creatures and their usual seasonal scheduling. And what happened here is seasonally, everything crashed in September in 2020. And now let's take a look at, we're going to put all the data together and look at how many flyovers did we record in Crow Valley each year from 2017 to 2020. Each bar is simply total flyovers by all bats. And you can see that it was very high in 2018, but then fell in 2019, well, by half. We lost half of our bat activity in 2019, and then it crawled up a little bit last summer. So actually, what we saw last summer seems to have started a year earlier in 2019. Now, what could that have been? I mean, it was enough to knock out roughly half of the bat activity in Crow Valley. And another look at this, if we look at which species of bats were included each year, so the community composition, which species formed the mix each year from 2017 to 2020, those bars are shifting. There are fewer, over those 4 years, the proportion of California bats went down a little. The proportion of Yuma bats and the proportion of little brown bats increased. So there was a shift away from California bats to humas and little browns. What could possibly have caused a reduction in one of these three closely related species and an increase in the others? Well, one thing was, well, the replacement, if there were fewer Californias, then there was food available for others to take. But why those? And what caused the Californias to decline so sharply in 2019? So at this point, we can only hypothesize. Climate change, yes, I mean, 2019, 2020, we're beginning to see stormier springs where insects emerge later, they're different insects. And during the winter, which sort of extends into April, May, from a bat's point of view, there are fewer nights you can fly because it's so stormy. So probably more winter mortality from being cooped up more, and less food for the moms and the pups in the spring due to this stormier weather that we're experiencing right now, this month and the last 2 months. Second important possibility is of course habitat loss, that places that produce insects or that provide homes for bats are being lost. This is always what conservation biologists worry about, is that critical habitat for food or for shelter, for reproduction is being lost. And that could include roosts in homes, orchards, woodlands, that would result in fewer colonies, smaller colonies. We don't really know. We don't have a way of measuring this. It's just at this point one of the most convincing possibilities, but something that we definitely need to take a look at more closely in terms of information on particular roosts. Disease, I would say probably not. Bats in the San Juans are very healthy. They don't have rabies. They have not had any white nose syndrome and are not considered at risk because they don't hibernate in caves. And despite some worry we had a little earlier in the pandemic, they have not, so far as we can tell, contracted any new coronaviruses. So we have healthy bats as far as we know. They may not have enough space and they may not have enough good flying weather when they need it, but they're not showing any signs of contagious disease that would explain the drop. And the last thing is, of course, we're concerned in many ways about toxic material in the environment. Could bats be drinking polluted water, eating poisoned insects, insects that got non-lethal or sub-lethal doses of pesticides? Absolutely. We have no direct evidence of that, but it's entirely possible that one thing that has happened is a change in pesticide use and exposure of bats to pesticides. So here's the kicker. Here's our to-do list. You know, what can we do? What can we do as islanders, as gardeners or farmers, as homeowners to help out bats and make sure that we don't end up in a steady decline rather than just this rather nasty hiccup that we see in bat abundance over the last 2 years? Well, one easy one is really to lay off the pesticides, because if you poison insects, the insects that don't die convey the toxics that they've eaten to the bats that eat them. And so anything that you apply that will kill insects is definitely a threat to bats that eat the half-poisoned insects at the edges of your application, and or the ones that are poisoned by residual pesticides in the environment. And so a very, very serious appeal, I think, would be made by any bat biologist to minimize the use of chemicals. Use bats as biocontrols. Don't poison insects and then expect the bats to help you out, because you're poisoning the bats too. the bats that need cavity nests are really, really in trouble because we cut down a lot of our old knotty trees like this, gnarly trees. Natural tree cavities, which are not just in oaks, as I've actually heard some conservationists here say, well, we need more oaks because of cavities. They're not the only tree that has cavities in them. Doug firs have cavities, and apple trees, old orchard trees, have loads of tree cavities like this. And those are very important because birds, bats, squirrels, we do have native squirrels, that's a whole other story, but birds, bats, small mammals will use these cavities for nesting, and definitely cutting down trees that could be supporting wildlife should be carefully considered. And the easiest thing to do is let's save and prune and care for our old apple orchards because they are full of tree cavities that bats and other small animals can use. And so let's bring them back, produce the fruit, keep beautiful trees, and take advantage of the fact that unlike young fruit trees, they have lots of cavities, lots of hollow stems that that bats can use. And finally, back to this issue about bats liking to live with people. The trick is to make space available for bats around your home, but not where you don't want bats. Most homes in the islands are built with the kinds of spaces that you see in these pictures that shouldn't be there because bats will use them and will try to get into them. Joints and beams that don't fit together tightly, and space behind fascia, beneath the eaves, all sorts of nice little warm crevices that are either on the outside of a house or just inside through a crack or a crevice that was not properly screened or properly joined when the house was built. And so the issue is often not one of bats shouldn't be on or in houses, but plan where bats go. One way to do that is to install what we call a limpet. This is one of ours that we built for bat conservation, and it's basically a controlled bat area under the eaves where it's nice and dry and warm on the south side of a house. It's big, but it's flat. It's designed to be very warm. It's insulated, in fact, very, very thick, and placed right where bats were getting into the building to begin with. So when they come back the next year, they won't find the hole that they went into to get into the attic. They will find this nice warm shelf that they can climb into that's in just about the same place. And even a board or a couple of boards nailed beneath the eaves to create a shelf, just a very, very narrow shelf, an inch or two space between the shelf and the roof where it's going to be nice and warm, can create a wonderful bat house on the outside of a building that bats will like just as much as getting inside the attic. So modifying the eaves and the roof line and creating space for bats on the outside of a house while not leaving spaces for them to get inside the house where they are going to get in trouble and you may end up trying to get rid of them. This is really important because you can create a lot of bat habitat without freestanding bat boxes, without creating, just by working with a few boards, if necessary, underneath a roof line. And so taking a look, making sure that you aren't inviting bats into places that you don't want them, but seeing that there are some nice warm shelves or boxes or compartments under the roof, in the eaves, on the outside, means that you will probably have your biocontrols moving in with you and moving in to a place that you expect them and where you're comfortable with living with them, rather than in a situation where, unfortunately, where it becomes a conflict between people and bats. So, wow. Well, I'm just going to finish very briefly by saying we appreciate some folks, some foundations that have helped us pay for all those bat recorders. Wildlife Acoustics, which builds the bat recorders for us, and Wolf Hollow, which is a partner in bat research, as well as bat biologists like my teacher, Ella Rowan, that have introduced us to just how fascinating bats are, and hope that you will follow up in many ways to help us protect this astoundingly interesting widespread biocontrol in our community that above all protects our orchards and our fruit-bearing trees generally. So thank you so much. And I will turn off my screen.
Thank you so much, Russell. There's so many thoughts that I have listening to this. But one of the things that I'm going to take with me is the happy sounds. Those, those hardworking mothers, and then what we can do to help. And I'm left with a question that which I think good talks always do, is leave you with questions. And I'm really interested now in the relationship between the mother birds who are desperately hunting for caterpillars and the bat mothers who are desperately hunting for the moths, and how that interacts.
Yeah,
just
fascinating. That really is the big ecological question. You have the night crew and the day crew, as it were, and they're very closely tied because they are eating different life history stages of the same species of insects, which means that we have to manage birds and bats as if they are what an ecologist would call a guild, that all work together on the same, basically the same job. And that's critical, that we recognize that the day crew includes some birds that have been in trouble recently in the region, like some of our swallow species, and that it's not a good idea to let that relationship between the day crew and the night crew go far out of balance, because it'll make it difficult for the others to come back in later on. So I very much take that point that good bat conservation is always tied to good bird conservation.
Interesting. Thank you so much. I think Holly probably has questions for you, but
I do. There are a couple questions that came in through chat. So Russell, the first one is, how does the bat recorder know which bat is flying over it?
Okay, the recorder is set with bandpass filters that just zoom in on, just respond to the range of vocalizations, the range of sounds that bats make. So it's about 20 kilohertz to 120 kilohertz that we record at. And that gets a lot of noise out, and people's voices and birds and things like that don't record in that range. So we're already cutting out 90% of the sounds in the background simply by restricting which frequencies of sound the bat recorder responds to and records. Then the magic happens at the laboratory when we run those recordings back through a kind of machine intelligence program that compares the recordings to each other and to reference recordings it has in a digital library, and determines what the most likely species is, in sort of the same way that we listen to birds and we hear a bird call and say, oh, that sounds like a dark-eyed junco. And the machine is doing the same thing, but doing it extremely fast so that it can run through thousands of recordings an hour. In fact, our lab currently is working on a system that will do the same thing for bird recordings. And we have about a year's worth of bird recordings that we are now preparing to run through the system, where we can have a machine listen to, say, 10,000 bird songs and give us numbers. So many dark-eyed juncos, so many towies, so many, instead of having somebody listening individually, which would take weeks or months. So the basic answer is we have an archive of verified or validated recordings of these species. And just like the Cornell or Seattle Audubon archives of bird songs, that gives us a basis for comparing each recording that we make with a recording set of the 9 bats that we expect to be hearing here in the islands, except we do it digitally. It's done by machine instead of done by somebody with a set of headphones. When I started, it was done by somebody with a set of headphones, and in 10 years, we've moved to machine learning.
Okay, thank you. Next, oops, I gotta scroll up a little bit. Is there any correlation of activity to daily temperatures?
That's what we're trying to find out now. That's a really spot on question. Weather generally, temperature, precipitation, wind, and many bat biologists are absolutely convinced that moon phase, that the amount of light at night, cloudiness and moon phase, may all be factors in whether bats decide to fly and how far they fly. So currently, our poor long-suffering mathematician who's on Orcus is working on algorithms to go through the weather records for the islands and correlate them with the recordings that we've made over the last 4 years and look for patterns of correlation between temperature, wind, cloudiness, moon phase, and bat activity. And it's very exciting because, surprisingly enough, nothing like that has been done before, certainly not with a database this huge. And we may be able actually to get a sense of bats' flight planning, of what factors are critical in a bat's decision to go out on a particular night. So yes, a great question. And the answer is, that's what we're working on now. That's the current phase of our research, is that correlation of weather with activity.
Cool. Okay. The next one is, can we get instructions to make an appropriate bat house?
I'd be very happy to share digitally with anyone. We have some blueprints that we did a number of years ago that Nathan Hodges in our eco design group did a few years ago for adequately insulated, suitably sized boxes for maternity colonies. And those designs are free, and anyone that wants to email our information email, info@quiot.org, and ask for one, we'll get one by return email. We've changed our minds over the years, and we're working on some new ideas and new designs. We'd love to involve interested homeowners in it, to try to get even more simple, because we really have found that that a single cedar board nailed up in the right place underneath the eaves in a nice warm spot of a house can end up with as many bats as a $200 or $300 cedar box. that is beautiful, but probably over-engineered for most bat uses. And so rather than going, we started out with bigger boxes than the ones that you can buy online or in the store, much more insulation. We even have electrified boxes that heat themselves using garden mats and things like that. And they work, but they cost a lot. So we now have a kind of a Mercedes bat box design that we're happy to share, and it does work. But we think that we can make it simpler so that anyone with a hammer and nails and a few 2x6s can get pretty much the same results in an afternoon, rather than going for something that we think of as a bat box. But from a bat's point of view, a small, warm, dry space under the roof is a small, warm, dry space under the roof, regardless of what it's part of.
Okay. So do you, what if you were to email those instructions to Nita, and Nita could send them out to the garden club?
Absolutely.
And anyone else who's interested could contact either me or Nita if you're not a member of the garden club and you're watching this.
Yeah,
okay,
perfect.
we have 2 more. The next one is the person says, I have big brown bats in the attic of my guest house. Who can I hire to close off the entry holes and build an outdoor bat house? So kind of on the
Ah.
coattails of the last one.
Yeah, it is. It is. Everything depends a lot on the individual situation, and I have seen so many different ways that bats are getting in. The first thing that we recommend is to do a very careful check of anything that's open at night, like windows or doors, and very frequently find that an open door between sunset and about an hour after sunset, even if it's open for 5 minutes, a bat will fly in and it goes unnoticed, and then it's a mystery because you can't find any other way it could have gotten in. So checking windows and doors, ventilation, or just looking for anything obvious. Chimneys, chimney caps should have wire over them. Flashing around chimneys is also a vulnerability. And if you still can't find an explanation for how bats got in, then definitely contact us, contact our lab, and I will come over and take a look. and we can talk about what kind of a design would be best to replace any habitat that might be lost by sealing up the entries to the house.
Excellent. Okay, thank you. And the last thing that I have, unless anyone else, last chance to submit your questions. The suggestion is let's rename Crow Valley Bat Valley.
Well, it's actually interesting. It is one of the battiest places in the islands. It's second only to Hummel Lake on Lopez, which gets up to 1,500 flyovers a night, which is almost unimaginable. I mean, the sky is black with bats. But Crow Valley is very batty because there are several buildings that have bats in attics that that have been properly insulated and separated, so the bats are being left in the attics and they don't have any effect on the living space outside, essentially separating the attic from the rest of the building. Something we've done with at least one historic building in the county where the bats live in the attic and it's completely sealed off and people live downstairs. And under those circumstances, there's at least one colony of over 1,000 in Crow Valley. So it is very batty. I hope it stays that way. It's an ideal habitat. And yes, we've heard all 9 species in Crow Valley. So batty it is.
That's funny. Okay, someone just popped up a question that was running through my head at the same time. Doesn't the bat guano collect in the attics then?
So bat guano is actually something gardeners should pay attention to because it's superb fertilizer.
Okay.
It's just chewed up, partially digested insects. It's mostly exoskeleton, so it's mostly pretty neutral. Doesn't really smell that bad actually if it's been aired. So fresh guano actually is a resource. And one of the first people to get one of our bat houses, like one of those limpets that I showed in the slideshow, on his own, as a gardener, it's John Stamey, who is the bamboo man on San Juan Island. And John looked at that house and it had guano pouring out of the bottom of it because he had about 400 bats, and built a box underneath it with a screen over it and started using the guano in his garden. That gave us the idea that bat houses that can have shelves in them, the way bird houses often do, and that in attic spaces and enclosed spaces, if you put down a sheet of plastic, for example, now and then you can just go and scoop up the guano and bag it and put it in the garden. It's not going to be toxic to people. We have no diseases associated with bat guano here in the islands, so it's safe to handle, other than just being dusty if it's an enclosed space. And so building a surface, a platform to collect guano, and it can literally be, if it's a small enough space like a corner of an attic, a shelf or a drawer. to collect guano is great, because then you're converting something that over time would be potentially problematic into a resource. It's rare to have very much guano inside a building unless you're one of the rare homeowners in the county that has a truly big colony. Like there's one on Lopez that's probably about 1,000 mouse-eared bats, and they get 2 or 3 wheelbarrows full of guano a year out of that. But the answer there was to line the area with this queen, with thick plastic, and just collect it, clean it out once a year, put it in the garden.
Excellent. I'm glad to hear that there's usefulness for bat guano.
There definitely is. It is excellent.
Would now be an appropriate
No,
time.
seriously, I went to just one last thought on that. In some of the hardware stores here, the garden stores here in San Juan County, they are selling bat guano for $10 a pound.
Local bat
Gardeners
guano
are
or
buying bat guano in
Okay.
San Juan County,
That's funny.
just in boxes.
Don't do it.
Yeah.
Do you have a moment to talk about the bat detectors that we have here at the library? Because they're not as powerful
Sure.
that you showed, but we do have them available to loan out to patrons.
Oh yes. Oh no, it's wonderful. One of the coolest things you can possibly do is use some of these very simple handheld bat detectors, which basically convert the ultrasonic chirps of bats into audible sound, and suddenly you're in the jungle and you hear all this wonderful chirping and squeaking, and it's like suddenly there are birds everywhere in the middle of the night. It's the most fabulous experience to suddenly hear the night the way bats hear the night. And that's what these are designed to do. They don't do analysis. They don't, there are newer versions of these things that do, but the real joy is not in being able to count how many California myotises flew overhead, but to hear them like a flock of birds chirping away, and then little ecstatic buzzing as they all start swallowing their evening meal. And that you can hear perfectly well with the kinds of instruments that the library has.
And we have one that goes to iPhones and one that goes to Android. So yeah, when you come in to check one out, make sure that you're getting the right one. And then it just plugs into your phone and you download an app and you're ready to go.
And you're ready to go. It's very simple and works very, very well. And yes, it has some basic analytics in it, but just the sheer joy of just turning the thing on and forgetting that you're just listening, like sitting in the middle of a meadow on a sunny morning and listening to the birds. Suddenly it's a whole other dimension of the outdoors, and I would strongly encourage people to try it out.
Okay. Excellent. Thank you. You've gotten lots of thank yous in the chat, so I want to add mine. This was fantastic. I really enjoyed it.
Thank you.
Lena, anything here at the end? You're muted. There we go.
I thank you so much. That really, and I'm going to go get one of those and listen to those bats.
Great.
Okay. We're open till 5 today, Lena. We'll see you.
Thank you. Thank you.
Okay.
This was
Well, thank
great.
you all. It's always a pleasure to talk about fascinating things that make our islands super special, and this is one of them.